My name is Sanne Moorman and I'm a behavioral neuroscientist at the University of Groningen. In my research group, we study the neural mechanisms of song learning and memory in songbirds as a model for human speech acquisition. Songbirds and humans are not very closely related in evolution, and also our brains look very different. However, we both have this unique ability to imitate sounds from our environment and learn to make the right vocal movements to also produce those sounds. And we use this when we learn to speak when we're infants. And songbirds also need to learn their songs this way. So they're not born with their final song. They need to actually hear others to develop their own song. And there's many examples of songbirds who do this: zebra finches, starlings, sparrows, nightingales. Each songbird has their own unique song, but they also have individual differences, and they need to be able to hear others to produce such a song, just like we learn to speak. Both humans and songbirds rely on the ability of vocal learning to develop their sounds. And most other animals, even though many make sounds, do not rely on this mechanism. In fact, they do not need to hear say members of the same species vocalize, or they don't need to hear themselves vocalize in order to develop their vocalizations. And if you compare the brains of a non-vocal learner with a vocal learner, there are some distinct differences. And so we have specifically dedicated brain regions that support vocal learning. And so the brain anatomy and the brain function of vocal learners is different. And so if we want to understand the mechanisms for speech, we need to look at the brain of a vocal learner. So yes, songbirds have the ability to recognize individuals just like we do by using voice cues. And one of the ways in which this was shown is that birds were trained to peck two different keys when they heard individual A or individual B. And they were able to learn to do this correctly, to make that categorization. Then they also presented other sounds made by those same individuals, so different call types, that they had never heard before, and they were able to categorize them correctly immediately, showing that they could use the voice cues to recognize the singer. To be able to keep zebra finches in the lab, we have to adhere to European guidelines on housing requirements. And so there's a minimum cage size of 1 square meter floor surface and 1 meter height that we need to adhere to, and they need to be housed socially in the lab. And this is also helpful for ourselves actually, because this helps them to perform their natural behavior, which is singing. And if we house them this way, we only need to put a microphone in the cage, and then we can record the behavior that we're interested in. And this also alludes to the other part of the question: is can they be trained? Yes, they can be trained, but for most of the experiments that we do in our lab, we do not need to train them. We just need to make them do what they always do, is sing. There are some options to study brain processes in artificial neural networks, brain organoids, or in post-mortem human brain tissue. However, to really understand how neurons encode experiences, how they change with learning, and how they really drive the natural behaviors that we're interested in, such as vocal learning, research in animals is the only option we have. With this research, we're able to generate knowledge about how the brain works, how we use it to learn, speak, and interact.